Hello, everyone, and welcome. I'm Russell Blank, your NEC consultant and code expert. In this video, we're going to be discussing branch circuit calculations for electric ranges in dwelling units. So if you'd like to grab your 2023 code book and a calculator and maybe a pen or pencil and some scrap paper, you can follow along and we can dive right into these. Okay, in Article 220, we are in Part 2. We are doing the branch circuit load calculations, right? We're not doing feeders, we're not doing services, we're doing branch circuit load calculations. And we are doing these calculations for electric cooking units. This is according to 220.14b. This includes ovens, cooktops, and ranges. And it doesn't matter if these are resistance style heating elements or if they're induction heating. It doesn't matter. Calculations are the same. There's no distinction made between the type of heating that's used, whether it's resistance or induction. 220.14b allows us to use the feeder method. It says the branch circuit load calculations, right? The branch circuit calculations are permitted to use the feeder or service calculations as specified in 220.55 for electric ranges and other cooking appliances, right? So if you want to, you can use the feeder or service calculations to calculate your branch circuit load, right? That's pretty cool. Gives you a couple options. Let's take a look at 220.55. And again, it's giving us permission to do this, right? You don't have to, but you can if you want to. The load for household cooking appliances, individually rated higher than 1.75 kW, shall be permitted to be calculated in accordance with Table 220.55, right? So you don't have to do this method, but if you want to, you can. And for the purposes of these calculations, kVA is considered the same as kW. Now, if we don't want to use the table, right, because it is permissive, right? You're not required to use the table, but you have permission to. If you don't want to, you could use the nameplate. You could absolutely use the nameplate to size your branch circuit. And so let's take a look at this nameplate and size the branch circuit and see what happens. Okay, there it is. It will say it's at 240 volts, so that means the nameplate would be 13.3 kilowatts, and we would have to use that whole value, the whole 13.3, to figure out the branch circuit if we want to, right? And that math would look like this. The nameplate was 13,300 volt amps, or 13.3 kilowatts, right? If we divide that by the system voltage of 240, that gets us to 55.4 amps. That means a 60 amp branch circuit would be needed. Wow, right? So a 60 amp branch circuit is a whole different animal compared to a 40 amp or even a 50, right? Creates a whole nother set of issues to deal with, like the receptacle and the wire size and the breaker size, et cetera, et cetera. So if you ran a 60 amp branch circuit, you have to follow all the rules for a 60 amp branch circuit. That might be problematic if you wanted to quote and plug connect this, for example, or if you wanted to hardwire it, right? You're talking about a disconnect and a receptacle. So all the rules for a 60 amp circuit would be applicable if that's what you've determined the branch circuit load to be. So perhaps using Table 220.55 might allow us a smaller rated branch circuit. Maybe a 40 or 50 amp branch circuit might work, and maybe that's a little easier to deal with, right? Okay, here's my version of Table 220.55, right? And the heading says column C to be used unless column A or B is permitted per note 3. And so the first column is the number of appliances. Column A is for nameplates less than 3.5 kW, and the values there in column A are percentages of nameplate. Depends on how many appliances you have. It could be 80, 75, 70, 66, and so on and so forth. Column B is for nameplates 3.5 to 8.75 kW, and again, those are percentages of nameplate. Now, column C is for every nameplate, right? Column C to be used in all cases. But the thing with column C is the values in column C are actually KW ratings, right? It's the maximum demand, KW. And as long as your nameplate does not exceed 12, then it's just a matter of reading column C as it is, and that's it. Whatever the number is in column C, that's what you use, right? So if I told you it was one appliance, column C, you could use 8 kW. And that's it. You just use 8 kW, and that's the minimum calculated load. And that's it. There's nothing to do you don't have to modify it or anything else, as long as the nameplate does not exceed 12. If the nameplate exceeds 12, then we got to talk about that. We might have to modify the values in column C, and we'll do that in a minute. I want to focus on note 3 first of all. Note 3 says instead of column C, or in lieu of column C, you can use column A or B as applicable. All right, so you really have 3 choices if you think about it. You could use your nameplate. You could do that, or you could use column C, or you could use column A or B as applicable. So that's why these calculations can be difficult sometimes, because there's potentially 3 ways to do it. And they're all correct, right? They're all correct. They're all permitted. You can use a nameplate. You can use column C. You can use column A or B as applicable. But if you're taking an exam and the question says, what is the minimum permitted calculated load? Well, that kind of forces your hand a little bit. And you might be looking at 3 calculations to try to figure out which is the smallest value. Okay, they may all be permitted, but only one in that case would be the minimum permitted. Okay, now let's talk about these ranges where we might have to modify the values in column C. And that's note 1 to table 220.55. Let's take a look at that. Okay, note 1 says, for ranges having nameplate ratings more than 12 kW but not more than 27 kW, the maximum demand in column C gets increased 5% for each additional kilowatt, a major fraction thereof, by which the nameplate exceeds 12 kW. Okay, so we may have to increase the demands in column C, 5%, 10%, 15%, some factor of 5%. There's a couple other notes we want to look at. This one's very important. Note 4 says calculating the branch circuit load for one range in accordance with table 220.55 shall be permitted, right? So again, it's not mandatory, but you have permission to do that. And it's important to understand, which appliances we're talking about here, right? And so this is a range on the screen, right? That's a range. Table 220.55 is permitted to calculate the branch circuit load for one range. But then we have note 5, and that says the branch circuit load for one wall-mounted oven or one counter-mounted cooking unit shall be the nameplate rating of the appliance, right? So we have to understand what's a range, what's an oven, and what's a cooktop. All right, so that is an oven on the screen there, right? And note 5 says use the nameplate. Do not use table 220.55. Use the nameplate instead. And then we have a cooktop. You got to use the nameplate to calculate the branch circuit load for a cooktop as well. So for ovens and cooktops, it might look something like this. We put in a branch circuit, a circuit breaker for the branch circuit. And for the oven, we would use the nameplate to size the first branch circuit. And then we would run another branch circuit to the cooktop, and we would use the nameplate rating of the cooktop, right? And so in both of these cases, we're going to use the appliance nameplate for sizing the branch circuit. But sometimes what might happen is, let's say you're doing a renovation, or the customer just, bought a couple appliances, for example, right? And maybe you show up and the panel board only has space for one 2-pole breaker. And so you can't put 2 separate circuits in, right? That's a bummer. So you might be looking at adding a sub panel, or ripping out that panel and putting in a bigger one, for example. And well, the price just went way up for the customer, right? Just because you didn't have space for one more 2-pole breaker. There's another note we want to look at. right? So maybe we could use note 6. Note 6 says this: the branch circuit load for one counter-mounted cooktop and up to 2 wall ovens, all supplied from the same branch circuit and located in the same room or kitchen, shall be calculated by adding the nameplate ratings of the cooktop and the ovens and treating this total to the equivalent of one range. Ooh, that sounds pretty good, right? So we might be able to do something like this. Run one branch circuit for both of these appliances, right? And we would just treat it as if it was one range. That's pretty cool. And what we would do is add up the nameplates. We would add up the 3 kW from the oven plus the 6 kW of the cooktop. And for the purposes of sizing the branch circuits, we would call those two things, those two appliances would be the equivalent of one range. And if it was a range, we could actually use table 220.55. So instead of using 3 kW nameplate for one branch circuit and 6 kW nameplate for a second branch circuit, we could use 9 kW and size the branch circuit that way and hit both of these appliances based on the branch circuit calculated using table 220.55. That's pretty cool, right? Instead of ripping out the panel board or putting in a sub panel, right? You just put in one 2-pole breaker and you hit 2 appliances. It might look something like that, right? You put your circuit breaker in, you run your branch circuit to a junction box, or maybe a couple of junction boxes, and then you bring the appliance whips into those junction boxes. And then you are splicing the appliance whip leads right onto the branch circuits. Now, there's a very good chance that the leads from the appliance would be considered taps, and there are some rules, special rules for taps in section 210.19C, exception 1, that you want to read. It'll establish the minimum sizes and things like that. Very important to pay attention to those. Okay, so again, if you don't have space in a panel board and you didn't, or maybe you just don't want to run 2 branch circuits, right? One for the oven and one for the cooktop, you could run one branch circuit for both appliances and treat it as the equivalent of one range. That's pretty cool. And again, instead of using a nameplate, you could use the 9 kW rating, take that information and go to table 220.55 and figure out what size branch circuit you might need that way based on the branch circuit load calculation. Now, note 3 allows up to 2 ovens and 1 cooktop to be in the same room and on the same branch circuit and treated as one range for the purposes of calculating branch circuits. So that's cool, right? So instead of needing 3 spots in a panel board for 3 2-pole breakers, you could instead put 1 2-pole breaker and hit all 3 of these appliances with this one branch circuit based on the branch circuit being the equivalent of one 12 kW range. So instead of a 3 kilowatt branch circuit and a 3 kilowatt branch circuit and another 6 kilowatt branch circuit, you could run one branch circuit as if it was for one 12 kilowatt range, and you take that 12 kilowatts and go to table 220.55 and you do the calculation that way and figure out what size branch circuit you need as if it was one range, right? So that saves you some space in the panel board. And in that case, the branch circuit might look something like this. You put in a circuit breaker, just one branch circuit instead of 3, and then you run your branch circuit wires to at least 1 junction box, maybe 2, or maybe 3, depending on how far apart these appliances are from each other. If they're very close to each other, you could just take the fixture whips. Typically, it's a flexible metal conduit with the appliance leads in it, and you can bring that into the junction box and splice onto the branch circuit wires. That's pretty cool, right? And again, for the purposes of calculating a branch circuit load, these 3 appliances are the equivalent of one 12 kilowatt range. That's pretty cool. And if it was a range, then you can use table 220.55 to figure out the branch circuit instead of using the nameplates for sizing 3 branch circuits. That's pretty cool. Okay, let's do some more examples here now. All right, table 220.55. This is example 1. The nameplate here is 10 kW, All right. There's your nameplate there. So try to find the minimum permitted branch circuit load. All right. So if you want to pause the video, you can, and try to figure out what you have to do with table 255 and figure out what size branch circuit you might need. And then when you're done, you can come back and start, and I'll give you the answer, okay? Okay, let's take a look at the table. 225 and figure out this answer here. All right, a 10 kW nameplate only fits in column C, doesn't fit anywhere else. Right? So you just have to read column C, and that's it. You're all done. 8 kW. That's the minimum permitted branch circuit load calculation. Okay, let's do another one. And notice on this nameplate, there are two ratings, right? We have the 12 kilowatt rating. That's for when it's connected to 120/240, or 9 kW when it's connected to 120/208. You might have 208 in an apartment building, for example. So in that case, you use the 9 kW for doing your load calculations. In a house where there's 240 volts, you use the 12 kW rating. Okay. All right, so we're going to stick with the 12 kW rating. We'll say it's connected to 240 volts. All right, again, find the minimum permitted branch circuit load. So if you want to pause the video here, you can, and try plugging this information into table 255 and see what you come up with. And restart the video when you're ready. All right. If we plug that 12 kW nameplate into column C, the only place it fits is column C. It doesn't fit in column A. It doesn't fit in column B. So the answer again is 8 kW. So we had two nameplates, a 10 kW and a 12 kW, both with the same 8 kW calculated load. Okay, here's another example. This time the nameplate is 8.4 kW. Now, column C is still applicable, but this might fit into one of the other columns now. So again, if you want to pause the video here, try to figure out what's the minimum permitted branch circuit load. Give that a shot, and when you're ready, you can restart the video. We'll go over the answer. All right, find the minimum permitted branch circuit load. Well, we got to look at table 225, note 3. That's going to say use column A or B, whichever is applicable. Column C, you always have to use. Column C to be used in all cases. 8 kW, right? If we just want to take this and plug it into column C, we could say, hey, that's the load, 8 kW. Better than the nameplate, right? The nameplate was 8 kW. But note 3 allows this 8.4 kW nameplate to be plugged into column B. Right? So if we plug it into column B, we would take 80% of the nameplate. And so that math looks like this: 8.4 kW times 80%, that equals 6.72 kW. So that is the minimum permitted load, right? We could use the 8 kW. That's permitted. It's not the minimum, though. 6.72, that's the minimum permitted calculated load for the branch circuit. All right, here's another example. This time we're going to say the nameplate is 3.49 kW, right, at 240 volts. Give it a shot. Try plugging this into column A or B or C, wherever it fits in table 225, and figure out what's the minimum permitted branch circuit load. Pause the video when you need to and restart when you're ready. Okay, we could take that nameplate and plug it into column C if we want, and then we would be using 8 kW. Okay, it's permitted. Remember, you have permission to do that. You could say the minimum permitted load for this 3.4 kW appliance is 8 kW. It's permitted. You could say that that's the minimum permitted load, 8 kW. But note 3 also allows column A to be used. All right. Well, if we use column A, we're going to use 80% of the nameplate. And so that math looks like this: 3.49 kW times 80%. That math works to 2.79 kW. So if you have a test question, for example, and it says, what's the minimum permitted calculated load? The 2.79 kW, that is the minimum permitted calculated load, right? You could use a nameplate, you could use column C, or you could use column A. They're all permitted, but only one of those is the minimum, and in this case, it's column A. And again, that's what can make these cooking unit calculations so difficult, because they might be three permitted calculations. Only one of them provides the minimum calculated load, though, and in this case, it's column A. That's the way for this one. All right, now we have another example. Example 5. We're going to be sticking with the 240 volt rating there, so we're going to be looking at the 13 kW rating. Okay, for this one, we want to, again, find the minimum permitted branch circuit load. And in this case, we want to take a look at note 1 to table 220.55. But give it a shot. Pause the video when you want to, and then restart when you think you've got the right answer, and then we'll go over the answer. All right, if we take a look at note 1, it says, for ranges having nameplate ratings more than 12 but not more than 27, the maximum demand in column C, that gets increased 5%. For each additional kilowatt, a major fraction thereof by which the nameplate exceeds 12 kW. So if the nameplate exceeds 12, we have to increase column C by some value, 5%, 10%, 15%, some multiple of 5%. All right, so there's the maximum demand in column C for 1 unit. But because the nameplate was 13, we have to increase column C by 5%. Right, that's what note 3 says. I'm sorry, note 1. All right, so if we increase column C by 5%, that gets us to 8.4 kW. That's the minimum permitted calculated load for the branch circuit for that 13 kW nameplate. Okay, I'm going to try to make this a little bit easier, because some people have difficult times trying to figure out, what percentage do we have to add to column C? Is it 5%, 10%? Where are the breakpoints? So I've kind of written it all down for you. So for nameplates 12.5 to 13.49 kW, right, if those are the nameplates, you have to increase column C by 5%. And for nameplates 13.5 to 14.49, you have to increase column C by 10%. And for nameplates 14.5 all the way up to 15.49, that's going to require column C to be increased 15%. And for nameplates 15.5 all the way up to 16.49, you have to increase column C 20%. And we can keep going, but I'm going to stop there. And there's a reason I'm going to stop there. But you kind of get the idea, right? So it's a 5% increments. The next tier would be 25%, and then above that would be 30, and so on and so forth. I don't think you'd ever get a nameplate that big, to be honest with you, but it could be possible. So that's why I stopped at 16.49, because I think it's unlikely that you'll get nameplates greater than that. You could, and if you did, then you'd have to increase column C accordingly. And so if we have to increase column C by 5% or 10% or 15%, what would that math look like? It would look like this. If we had to increase column C by 5%, then the value in column C would be 8 kW plus 5% equals 8.4 kW. And for nameplates 13.5 to 14.9, that's an increase of 10%. So increase in column C by 10% would look like this. You end up at 8.8 kW, right? Column C is 8 kW plus 10%, that's 8.8 kW. And so on and so forth. For 14.5 all the way up to 15.49, that's a 15% increase to column C. And so you're at now 9.2 kW. If you've increased 8 by 15%, you're at 9.2 kW. And then the last one, if we have a nameplate 15.5 to 16.49, that results in an increase of 20% to column C. So it's the column C value, 8 kW for one appliance plus 20%, 9.6 kW, and that's the number you use, the 9.6 kW. That's what you would use to calculate what size branch circuit you need, right? That's the minimum permitted load, 9.6 kW. All right, so there's a bunch of calculations there, and these can be a little bit confusing to try to, calculate the minimum permitted load, but I'm going to try to make things a little bit easier for you. There is a shortcut, right? And based on all that stuff, right, the table and all the rules that go along with it, there's another very important rule. Sorry, I got something in my eye here. There's another very important rule, not in Article 220, but in Article 210, specifically 210.19c. That establishes for ranges, right, just for ranges, a minimum branch circuit of 40 amps for ranges 8.75 kW and more, right? So that's the smallest, regardless of your load calculation, right? Remember, if your nameplate is 12 kW, if you plug it into column C is 8 kW. Well, that's great, but 8 kW, if you divide that by 240, you might be thinking, well, that's 33.3 amps. Maybe I can run a 35 amp circuit. Nope, because 210.19c establishes a minimum of 40. 40 is the smallest branch circuit you can run for a range with a nameplate of 8.75 kW or more. Now, if the nameplate is less than 8.75 kW, well, then of course you could run a smaller branch circuit, right? But never a smaller branch circuit if it's 8.75 kW or more. Also, that minimum 40 amp branch circuit does not apply to cooktops and ovens. All right, so you could have a smaller branch circuit for a cooktop or oven. Not a problem there. So if we factor in the minimum, right, 40 amp minimum, and then some of that math I showed you of how to increase column C, right? When we break it all down, 40 amp minimum, and then try to figure out, well, what's the maximum kW rating that would be accommodated by a 40 amp branch circuit? Well, I've done that math for you. And if you look on the screen, I would write this down somewhere in your code book, maybe near all the notes at the bottom of table 220.55, and maybe make a note to see 210.19c. Also, right, at the bottom of the notes for table 220.55, make a note to yourself, 40 amp minimum, C section 210.19c, something like that as a reminder that there is a 40 amp minimum for a lot of these ranges. And a 40 amp branch circuit will work for nameplates 8.75 kW all the way up to 16.49 kW. That's an enormous group of ranges, right? All those nameplate ratings will work at 240 volts. A 40 amp branch circuit will work for every one of those ranges. Anything in between it. That's really cool, right? That's an awesome shortcut. And let's just prove that, right? Don't take my word for it. Let's prove it, right? So we have the minimum. 210.19c says 40 amp minimum for 8.75. All right, well, let's see if a 16.49 kW range will actually fit on a 40 amp branch circuit. And it does, right? Here's the proof. The nameplate 16.49 kW requires an increase of 20% to column C. All right, so that would look like this. Column C is 8 kW plus 20%. That's 9.6 kW. Right, 9.6 kW times 1,000, that's 9,600 watts, or VA. They're the same for the purposes of these calculations. So 9,600 VA divided by 240 volts equals, guess what? 40 amps. Yay! Right? Now, if you are in an apartment building, remember those nameplates I showed you, and they had two different ratings, right? One was for 240 volts, and then the other one was for 208. You got two different ratings. So if you're at 208 volts, a 40 amp branch circuit will work all the way up to 13.49 kW. You might want to write this note down as well, right? It might save you some time on the exam, for example. If you have a question on your exam, and the question is, what's the minimum branch circuit rating for a range, there's a pretty good chance that the answer is 40, because it works for so so many ranges. It works for everything from 8.75 all the way up to 16.49, or in this case, 13.49 if it's at 208 volts. That's an awesome shortcut. I love that. Let's prove it, right? You don't want to take my word for it that a 40 amp circuit is going to be enough. All right, so the proof is this, 13.49 kW. If we have to, a 13.49 kW nameplate requires an increase of 5% in column C. All right, and so that math looks like this. Column C, 8 kW plus 5%. That gets us to 8.4 kW. 8.4 kW times 1,000, that's 8,400 watts, or volt amps. They're the same for the purposes of these calculations. 8,400 volt amps divided by 208 is 40.38. Well, we have a fraction here. Do we have to round up to 41? No. 220.5b permits decimal fractions smaller than 0.5 to be dropped. Very cool. So we could say 40. We can just say it's a 40 amp circuit. There's your proof. Okay. I think that's it. I hope that you guys were able to follow along, and hopefully you learned some good stuff and a couple shortcuts there. Thank you for watching the video. Stay tuned for more. And for more information, please visit my website, russleblanc.net, www.russleblanc.net. Thank you all. I'll see you in the next video.